Hello again, this is Michael. Welcome back to The Joy of Code. This is episode 4, and today finally we will start to write some code. No need for me to talk long about it, let's get started straight away. Here I've got the Greenfoot main window open again on screen with no scenario currently open. We have seen that before in the last episode. So I start again by using the scenario menu and the open item in the menu to open a scenario. And here I've got the Trick the Turtle scenario, which is the scenario that we use for this episode and which you can download from the blog. So you should download this scenario yourself as well, so that you can open it in Greenfoot and try out what we do here. I open it, and here is my scenario on screen. As the name says, it has something to do with turtles, and Trick is the name of our turtle that we are going to program. Again, as before, here is the diagram of the classes on the right hand side. It is divided into two sections. There are the world classes and the actor classes. The world class, specifically turtle world, actually represents the world itself. So this large sand colored area that you're seeing here, which represents my world, is actually also an object. So that whole world is an object of class turtle world. And this object, the world object, gets automatically created and shown on screen by Greenfoot. And then the actor classes here, these are the things that can exist in the world and do something. So here we can see from the names of the classes that it has something to do with animals and turtles, what we're going to do today. As before, when we have a turtle, the turtle class is the one we're going to start with here. We can right click on it, we get a pop-up menu, we can create a new object of class turtle, and we can place it into the world. There's our turtle. And we have seen before as well that when we click the run button, the scenario runs and the turtle will do whatever it is programmed to do. So let's click the run button now. And what do we see? Well, we see nothing very much at all. The turtle just sits there and it's not doing anything. We can try that again. No, it's not doing anything. So why is this? We can investigate this by looking at the source code of the turtle class. We do that by right-clicking on the turtle class and selecting Open Editor. Oops, Open Editor here. That opens the editor for this class. And the editor shows us the source code. I'm going to make the font size a little bit bigger. You can either do that in the preferences. There is also a keyboard shortcut. If you click Control plus or minus on Windows or Command plus or minus on Mac OS, then the font size changes. So Command plus on my keyboard increases the font size so that it is a little bit easier to read for you. Well, maybe not quite as much. This is okay. So let's have a look at what we've got here. We have seen before that when we click Run, the ACT method gets invoked. I can also click ACT, that also invokes the ACT method. The ACT button invokes the ACT method exactly once, and the Run button invokes the ACT method over and over and over again. We can also right-click the turtle and we see here's the ACT method, and I can invoke it from here as well. Every time I do this, the turtle does nothing. And here we can see why that is. This is the definition of the ACT method. This here says, here's the ACT method, and between those two curly brackets following that header is defined what the turtle actually does when it is told to act. In this case, there is no code here at all. That is why the turtle isn't doing anything. So when we click Run here, the ACT method is actually executed over and over again, and the turtle over and over again does nothing. We can now start programming our turtle by writing code here in the ACT method. So I'm placing the cursor here behind the opening bracket and hitting return so that I'm here, and that is where we start writing code between the two curly brackets of the ACT method. This is the header of the ACT method. We will investigate that in more detail a little bit later on, but at the moment it's enough to just recognize it, that this is the ACT method. And method header is always followed by a pair of curly brackets, and between those we specify what we want to happen when this turtle acts. One thing we can write here is we can write move followed by a round bracket, parentheses, and we tell this turtle how many steps to move every time it acts. Let's start off with 1. So I tell the turtle move 1 step forward, and this is an instruction to the turtle what to do. Every instruction ends with a semicolon. So every time I give the turtle an instruction to do something, I put a semicolon at the end. So if you try that out yourself, you have to type it exactly this way. You will notice, you will make mistakes at some stage. If you get just a single character wrong, it will not work. You have to get it right, exactly character by character. Okay, let's try this out. We go back here. Now we see that the turtle class here appears somewhat striped. If it is striped, this means that the source code has been changed, and now we need to generate new machine code to run this. We write the source code here in Java. Our computer cannot actually execute the Java source code directly. The computer executes a form of machine code. So we need to get from this Java code that we have written to machine code. Luckily, that is very easy. There is an automated program called a compiler that can translate this Java code into machine code. And here is a button down here called compile, which runs this program to do the translation. So if I click compile, the stripes go away, and now this class, the source code, has been translated into its machine code equivalent, and now Greenfoot can use it and run it. So the short of the story is, every time we make a change to the source code, we need to click compile afterwards, so that Greenfoot can execute what we have written. When we compile, our previous old turtle will disappear. We create a new turtle that now has this instruction, and we try invoking the act method by clicking the act button. It appears almost as if nothing happens, but if you look very, very closely, the turtle actually, every time I click act, goes just a tiny little bit forward. We can see that a bit better if we click run, and there we see the turtle actually moves across the screen. It moves fairly slowly, because when I move 1 step forward, 1 step is actually just, in this scenario, just 1 single pixel on screen. So every time it moves just a very tiny bit. But if we do that long enough, and let it run, eventually it will crawl across the screen. Well, turtles are very slow, but for our program, let's make it a bit quicker. We can do that by just telling it to move more than a single step forward. Let's say we move it 4 steps on every act. So we have now changed the code. So we go back, we compile again, we create a turtle again and place it in here. Now if I click act, it goes a little bit further, and if I click run, actually it moves faster across the screen. Okay, let's try that out again. We can either drag this over or create another turtle, or if you remember last time, there's a shortcut for creating objects. That's shift clicking into the world, shift click here to create turtles. And if you run that, they all move across the screen. Okay, that's pretty good. Let's see what else we can do. I've shown you that the turtle can move. So how can we find out what the turtle can do? There is one way. We can just right click on the turtle, and we see here the turtle itself, the only method that it has here is act. So that is the method we have executed at the moment. That doesn't help us to discover more functionality, but we see here 2 submenus. There's inherited from animal and inherited from actor. There are more methods here that are inherited, and what that means is there's a clue here in the diagram. We can see that turtle has an arrow to animal, animal has an arrow to actor. This arrow means it's what's called an is-a relationship. It means that a turtle is an animal and an animal is an actor. In technical terms, this is also called inheritance. we say in Java terminology, turtle inherits from animal and animal inherits from actor. That means that the turtle is an animal, that is, it's clear in the real world as well. And an actor is anything that can exist in the Greenfoot world. So that means the turtle is an animal, and the animal, and with it the turtle, can act as a Greenfoot actor in the Greenfoot world. Now, because a turtle is an animal, the turtle can do everything that an animal can do. And because the turtle is also an actor, it can do anything that an actor can do. In technical terms, we say that turtle inherits all the methods from animal, and the turtle inherits all the methods from actor. So that means every method that is available for actors and for animals is also available for turtle. And we can see that in the menu here. If we right-click on the turtle, we can see here there are methods here that come from the animal class, and there are methods here that come from the actor class, and I can use those to instruct my turtle. So here, for example, somewhere is the move method. There is the move method that I have just used. So that tells me here the turtle has a method called move that I can call. And here in parentheses it says int, which means this method expects an integer number, that is one number, to be given to it when we want it to execute. So if I execute this move method, a dialog will pop up and says, you're about to invoke the move method. Move method has an int parameter, so please supply an int parameter. So a parameter is a little bit of additional information that this method wants to receive before it can execute. The move method specifically says, okay, how far do you want me to move? And it gives me the hint here with the int saying, you have to tell me a number. So there I can say I wanted to move, say, 20 pixels forward, and click OK, and then it moves 20 pixels forward. And I can invoke the same method from here. As part of my action, I can say I want to move, because a turtle knows how to move. If we look here, there's also a method called turn. There are actually a whole number of other methods, but that's the one we want to concentrate on now. Turn also has an int parameter. We can try that out. We turn. The int parameter is actually the angle, how much we want to turn. So I can say I want to turn 90 degrees, and click OK, and the turtle has turned 90 degrees. If we have the turn method available for the turtle, we can also write that in here as part of our act method. So I can tell my turtle to turn instead. Turn, let's say I want to turn 5 degrees at every act step. So every time the turtle acts now, it will not move anymore, instead it will turn. Let's try that out. I compile it. I place a turtle into the world by shift clicking. And this time now when I click act, the turtle turns a little bit. And if I run this, now I've got a rotating turtle. That looks pretty interesting. We can also try to do both together. So I can go here and say I want to move forward and I want to turn. So at every step now, the turtle will move and turn a little bit. What will that look like? Can you make a guess before you see it? What will happen when you move and turn? Let's try it out. I run it, and the turtle runs in a circle. Let's try that out. We can put another turtle in, and another turtle, and they all run around in circles. Now if we want to have it run in a slightly larger circle, how can we do this? Well, we just make it turn a little bit less. If we make it turn only 3 degrees after every step, compile that again, place the turtle in again, and run. Now it runs in a somewhat larger circle. Or if you want a really large circle, we turn only 1 degree with every step. Place this turtle here, and it runs in a really large circle, and then it hits the edge of the world. And you can see here our objects cannot actually leave the world. If they hit the edge, they just scrape along the edge. But it runs now in a nice large circle. We can have a slightly more complete look at what the methods are that are available to us by just double-clicking the actor class, and that will open up in a web browser the documentation for the actor class. And here is a section called Method Summary. I can make that a little bit bigger as well. It opens in a web browser that gives you a list of all the methods that the actor class has, and there are actually quite a lot of them. But here the interesting ones, the ones that we have used so far, is here void move distance and void turn int amount. So this one we have used and this one we have used. Let's have a look at how to read those specifications of the methods. This is the specification of the method. It tells us what the method looks like. So let's have a look at what that looks like. If a method is specified like this, void move int distance, it always consists of three parts. The first bit is the return, specifies the return value. Void means this method does not return anything, so it will not return a value to us when we call it. The second part in the middle here is the name of the method. That tells me the method is called move. And the third part is between round parentheses, a specification of what parameters this method expects. And a specification of a parameter always consists of two parts. A parameter is a little bit of additional information that the method wants when it gets called to execute. And it consists of two words. The first is a type that tells me what type of input is expected here, and the next is a name for the parameter that shows me, gives me a hint what this parameter is used for. So here this is telling me when I call the move method, I have to supply a number to specify the distance, how far I want to move. And then to call it, this is how we actually write it. We write the name of the method and then in round parentheses a value for the parameter. So if it says it wants a number, we give it a number and then we finish it with a semicolon. And the same for turn. Turn also doesn't return a value. The name is turn. It also expects one parameter of type int, this time for the angle. And this is an example how we might call this. So try this out. So far this is not really, it's not doing a great deal. Oh, let's make that turn a little bit faster again. So a bit tighter circle. So far our turtle isn't doing a great deal, but we have started to program and we can make our turtle move around either in straight lines or in circles. Try this out and then come back for the next episode. That's it from me today, and we'll finish here. Until next time, bye bye.